differentiation. The equation of a curve is show that dy dx. So usually when we're finding dy dx or the y prime from y equals something, we just differentiate explicitly. But this time we cannot rearrange this equation to get y equals something. So that's why we have to use implicit differentiation, and that's by doing d dx or d dy actually. So let's just use d dx on both sides. So we differentiate with respect to x on both sides. Now on the left we have a multiplication, so we have to use the product rule. This is called the product rule. This is a u prime, this is v prime, so the product rule is u prime v plus v prime u, u prime v plus v prime u, u prime v plus v prime u. So for the first term here, the u is y, the u prime is 1 dy dx. So when we are differentiating y with respect to x, just like when we differentiate x with respect to x we get 1, we also get 1 here, but since we use different letters, this is y, this is x, we're gonna have to multiply by dy dx. So if this is, for example, z, we're gonna have to multiply by dz dx. Okay, so now this is u prime, the v is just the same. For the v prime, this is v. For the v prime, this is the MF19 formula, so we get exactly the same e to the 2x, but multiplied by 2 because of the chain rule. The derivative of 2x is 2. Okay, so that's the v prime, the u is still y. So for the second term now, notice that the brackets is important here because this is minus something. So let's say the u is y squared, the u prime is therefore 2y dy dx. Okay, again y with respect to x, so times dy dx. The v is just the same, the v prime is, the derivative is just the same. This is u. Now we simplify e to the x dy dx 2y e to the x minus 2y e to the x dy dx minus y squared e to the x, and then we move the ones without the dy dx to the right. We move this to the right and we move this to the right, so we add and subtract both sides with the terms, and then we factorize the ones with the dy dx. So we factorize, we still have e to the 2x minus 2y e to the x. We factorize and then we divide both sides by the brackets, divide, and then and then here we multiply both sides by negative, so negative becomes positive, so negative becomes positive, positive becomes negative, negative positive, positive negative basically. Okay, so and then we are rearranging a little bit here, we are swapping the order here, we get this, and then we divide by e to the x here. Okay, so we divide both parts of the fraction by e to the x. So divided by e to the x, we get e to the x. Divided by e to the x, we get 1 basically. Divided by e to the x, we get 1. Divided by e to the x, we get e to the x. Okay, so again the process is, you can say, to multiply both parts by e to the minus x, or we can say divide by e to the x. Okay, so now we have exactly what we need to prove. Tangent is parallel to the y-axis. So the y-axis is the parallel axis, so this means the tangent is vertical. If a straight line is vertical, then the gradient is undefined or infinity, and that happens when the denominator is 0. So gradient m, or gradient, is dy dx. So we are solving dy dx equals infinity, which means the denominator should be 0. So that's why we are solving denominator equals 0. So we add e to the x to both sides, and we square both sides here. We get 4y squared equals e to the x, because if we square this, we multiply the powers, we get e to the x. Okay, so now we are ready to substitute here. From this original curve equation in the first part, we replace e to the x with 4y squared, just like this, and we replace e to the x with 2y because of this. So this is 4y cubed minus 2y cubed, which is 2y cubed. Divide both sides by 2, take the cube root, we get the y value. To find the x value, we're just going to use this equation here. We know the y is 1, so we ln both sides to get rid of the e here. We have only the x on the right, so x is ln 2, and therefore the coordinates are ln 2, 1. That's the final answer. Alright, I'll see you again next